we're told that the half-life is 6 hours. And before we even move on, we can use that to help us determine some important information. So an exponential function can look like this in its base form, a times b to the t power. We don't need to necessarily know what the starting amount is either. We don't need to know what a is if we were given half-life. We know half of a is left over after that time, and if you divide both sides from a, if you divide both sides by a, you'll get this. So half of it is left. Actually, I can replace t. Half is left after 6 hours. That's what that first equation can mean. Okay. So if you plug in 6 hours in for t, we're told that half of the original amount is left. And this is something we can use to solve for b. Right? To get b by itself, you've got to raise both sides to the 1/6 power. Because a 1/6 times 6 makes b to the first like we want. And now 1/2, let me get a calculator. Okay, so 1/6, I'll copy that decimal value to my clipboard. And now 0.5 to the 1/6 power gives me 0.89. And decimals are pretty important with exponential functions, so we'll carry a few of those out. Okay, now we know what b is in this exponential relationship. Now that we know that, we can answer the question. How much of a starting amount of 2.5 that goes in for a will be left after 30 hours? So we're going to plug in f of t equals 2.5 in for a, or exponential, the b that we just found using the half-life, and then the power is 30 because time is 30 in this part. Now if you plug that in your calculator, that will tell you how much is left after 30 hours. So I'll take this b, raise it to the 30th power, and multiply that to 2.5. So nearest hundredth would be 0.08.